Let us start with definition of complete graph. A complete graph is a simple graph in which each pair of distinct vertices joined by an edge. A complete graph on n vertices is denoted by Kn. So we can draw examples to complete graph now. First we consider K1. So what is K1? K1 is a graph having only one vertex. Okay. Now, next we can consider K2. K2 means there are two vertices and those two vertices are joined by an edge. Next we can consider K3, and in K3 we have to consider three vertices and each pair of distinct vertices are connected by edges. Now K4, we have to consider four vertices and we have to join each pair of distinct vertices like this. Next, K5. Now we can consider five vertices and we can join them like this. That means each pair of distinct vertices are joined by an edge. So in K1, we have number of vertices is 1 and the number of edges is 0. So here in K1, number of vertices and number of edges, we can consider that. Number of vertices in K1 is 1. Number of edges is 0. And in K2, number of vertices is 2 and number of edges 1. And in K3, number of vertices 3, number of edges 3. In K4, number of vertices 4 and number of edges 6. And in K5, number of vertices 5 and number of edges 10. Similarly, you can draw K6 and there are number of vertices is 6 and number of edges is 15. Okay, so this is the concept of complete graph. So a complete graph is a simple graph in which each pair of distinct vertices is joined by an edge. Okay. Next we can move to another definition. Incidence and degree. Now we can explain the incidence and degree by the help of a graph. So we can draw an example here. Okay. Now we can name the vertices and edges as follows. Here, this is the vertex V1, this is V2, then this is V3, this is V4. Now we can name the edges also E1, E2, E3, E4, E5, E6, E7. Here, when a vertex Vi, when a vertex Vi is an end vertex of some edge Ej, is an end vertex of some edge Ej, then Vi and Ej are said to be incident with each other. Here, in this figure, we can see that E2, E6 and E7, E2, E6 and E7 are incident with the vertex V4. Incident with the vertex V4. Okay. Two non-parallel edges are said to be adjacent if they are incident on a common vertex. In figure E2 and E7. E2 and E7 are non-parallel and they are adjacent edges because we can see a common vertex there, V4. Two vertices are said to be adjacent if they are the end vertices of the same edge. In figure, you can see that V4, V5, V4 and V5. Here we have the vertex V5. V4 and V5 are adjacent vertices. Also, V1, V4. You consider V1 and VE4. There is no edge between them and so they are not adjacent vertices. Okay. Next, degree of a vertex. What is meant by degree of a vertex? And it is also called a valency. Degree or valency. Okay. The number of edges incident on a vertex Vi where self loops counted twice is called the degree of a vertex Vi and it is denoted by d of Vi. And from this figure, you can calculate the degree of each vertex. And here we can see that degree of V1 is equal to 3, number of edges incident with V1, and degree of V2. There is a loop. E1 is a loop, then E3 and E2 connected to V2. So degree of V2 is 4. And degree of V3. Degree of V3 is 3. Degree of V4. V4 is 3. And degree of V5. Degree of V5 is 1. Okay. So this is the method of finding the degree of each vertex. Now here next we have the handshaking lemma. Here the handshaking lemma says sigma d of Vi equal to 2 times number of edges, 2e. Here I varies from 1 up to n. If there are n vertices, we can take a sigma I varies from 1 to n, d of Vi equal to 2e. How to prove this? For that, we consider a graph G with the E edges and N vertices. Okay, suppose we are considering the general case. So we can clean this portion now. Okay. Now consider a graph G with the E edges and N vertices. We can name the vertices as V1, V2, etc. Vn. These are the N vertices. Now we can see that each edge contributed 2 degrees. You can consider any edge here. You can see that each edge contribute 2 degrees. That is, this edge E7 contribute 1 degree to V5 and 1 degree to V4. Similarly, each edge contribute 2 degrees. Okay, so since each edge degree, since each edge contribute 2 degrees, the sum of the degrees of all vertices in G is twice the number of edges in G. And hence we have sigma d of Vi is equal to 2E. And from the above figure, we can see that if we are adding all the degrees, you can see that what is sigma d of Vi in the above figure. Here, number of number of vertices is 5. So I varies from 1 to 5. Now you can add degree of each vertex. So here we have that is equal to 3 plus 4 plus 3 plus 3 plus 1. And that is equal to 14. That is equal to 2 into 7. That is equal to 2 into E. E means the number of edges. Okay, this is known as handshaking lemma. Next, we have very important theorem. First, we can write the statement theorem. The theorem says the number of vertices of odd degree in a graph is always even. Number of vertices of odd degree in a graph is always even. We can move to the proof. Proof is also very important. Now, consider the vertices with odd degree and even degree separately. So, sigma d of Vi, I varies from 1 to n, can be expressed as sum of two sums, each taken over vertices of even and odd degree respectively. That means this is equal to sigma d of Vj plus sigma d of Vk. Here even degrees, here odd degrees. Okay, and we know sigma T of Vi is equal to 2E by handshaking lemma. And we know 2E, 2 into number of edges, multiple of 2. So this is an even number. Okay, so sigma D of Vi, I varies from 1 to n, is an even number. And also sigma D of Vj, even. This is also even. Why? Because here we are taking sum of even numbers only. Okay, so you can see that here in equation number 1, LHS is even, this term is even. And so from equation number 1, you can have sigma D of Vk over odd degree equal to sigma D of Vi, I varies from 1 to n, minus sigma d of Vj even degree. This is even number, this is even number. And so even number minus even number is even. And so sigma d of Vk is even. That means the total number of terms in the sum must be even to make the sum as an even number. And hence the proof. Okay. Next, we have a definition. A regular graph. A graph in which all vertices are of equal degree is called a regular graph. For example, we are considering a graph like this. Now we can join the vertices in this way. And here you can see that degree of each vertex is 3. That is, degree of Vi is equal to 3, where I varies from 1, 2, 3, 4, 5, 6. Degree of all vertices are same. And so, this graph is called a irregular graph. Next, another definition. Isolated vertex. A vertex having no incident edge is called an isolated vertex. That means, suppose we are considering a graph like this, and suppose here is a vertex, and here you can see that degree of this vertex u is 0. There is no edge is incident to this vertex u. Such a vertex is called an isolated vertex. And for an isolated vertex, degree is always 0. So degree of u is 0. So u is an isolated vertex. Similarly, another one, pendant vertex. Pendant vertex means a vertex with degree 1. Here, suppose this is the vertex V, this is the vertex W. And here you can see that degree of V is 1 and also degree of W is 1. And so that is a pendant vertex. A vertex of degree 1 is called a pendant vertex or an end vertex. Okay. Next we have another definition. Two adjacent edges are said to be in series if their common vertex is of degree 2. For that, we can draw one example here. Suppose here is one vertex V2. This is V1. This is V6. This is V5. V3. V4. And suppose here is one vertex V7. Here from V2 to V5. Okay. Here in this graph, you can see that V4 and V7 are isolated vertex. Okay. Is there any pendant vertex? V3 is a pendant vertex. Here we are considering two adjacent edges are said to be in series if their common vertex is of degree 2. Can you find any example here if you are considering? Uh, if you want, you can consider the first graph that we draw earlier. And from that graph, you can see that two adjacent edges are in series if their common vertex is of degree 2. Okay. And for example, we can mark edges here. Suppose this is the edge E and this is the edge F. You can see that E and F are non-parallel. Okay. The two adjacent edges are said to be in series if their common vertex is of degree 2. And here V1 is the common vertex and its degree is 2. Okay, so this is the method of identifying series edges. Next, another definition, null graph. Okay, usually we know a graph contains vertices and edges. If the vertex set is empty, if the vertex set is empty and then automatically the edge set will be empty. That means there is no graph. Okay, so a null graph must have at least one vertex. So what is a null graph? If we are considering a graph like this, there are so many vertices, but there is no edges, only isolated vertices. Such a graph is called a null graph. It is possible for the edge set E to be empty. Such a graph without any edges is called a null graph. Every vertex in a null graph is an isolated vertex. Okay. Now, let us stop now. Thank you all.